Okay, see, we had studied here up to
Sir,
we had
atomic number.
atomic
Atomic number.
numbers. We had
Yes.
seen the atomic numbers and atomic
Sir,
mass.
I think atomic mass, no?
Yeah. So we had seen symbols also, and in the last class we had learned the symbols.
Yes, sir.
So I hope everyone will be able to remember the symbols. Everyone remembers the symbols now.
Yes, sir. No.
Okay, so like here you can just see once more you can see all the symbols. Aluminium Al, argon Ar,
AR,
barium Ba,
B, BO,
boron B,
B,
bromine Br, calcium Ca, carbon C, chlorine Cl, cobalt Co, copper Cu, fluorine F, gold Au, hydrogen H, iodine I, iron Fe, lead Pb, magnesium Mg, neon Ne, nitrogen N, oxygen O, potassium K, silicon Si, silver Ag, sodium Na, sulfur S, uranium U, zinc Zn. Then we had also seen that there are some of the elements which are diatomic, that they do not exist as a single atom, that rather they exist as a combination of atoms. Like some of the elements, they exist in groups of two atoms. For example, hydrogen. Hydrogen exists as two atoms together. It exists as H2. Oxygen exists as O2. Chlorine exists as Cl3, Cl2. Fluorine exists as F2. So in the same way, there are different elements. Most of them they are diatomic from the non-metals. In the metals, they are monoatomic, whereas a few of the non-metals they are also triatomic. Some of them are octatomic, like phosphorus. Phosphorus exists as four atoms bonded together, that is P4. Sulfur exists as eight atoms bonded together, that is S8. So now we discuss about the atomic masses. So atomic mass of every element is the mass of the atom as compared with the mass of 1/12 of carbon 12. Okay. So the ratio you can consider it the mass of the element to the mass of 1/12 of the mass of carbon 12. We choose carbon 12 atom as it is almost available everywhere, and also the carbon 12 atom it does not release much of the radiation. So its change of mass is very less. So see how it is taken here. Atomic mass. The most remarkable concept that the Dalton's atomic theory proposed was of the atomic mass. So according to him, each element had a characteristic atomic mass. So every element has a characteristic atomic mass. Okay, so it can be characterized with its atomic mass. You can see that the atomic mass of an element, it is an identification of that element, you can say. In a way, it is an identification of the element. For example, if I say an element is there which has atomic mass 16, so there is no other element which can have atomic mass 16. It is only oxygen which will have atomic mass 16. Got it? So atomic mass is a characteristic of that element. If I say an element has an atomic mass 12, so it is not possible for all the atoms to have atomic mass 12. Carbon can have atomic mass 12. Got this? Chlorine will have an atomic mass of 35. Sulfur will have an atomic mass of 32. So the atomic mass of different elements is you can say that it is a characteristic of that element. You see? So atomic mass unit, it was written earlier as AMU. Now it's only written as U. According to the recommendations, it is now written as U, unified mass. So instead of writing as atomic mass unit, we just write it as unified mass or U. So how it is defined? It is defined as the mass of an element as compared with 1/12 of the carbon 12 element. So Why we chose carbon? So while searching for various atomic mass units, scientists initially took 1/16th of the mass of an atom of naturally occurring oxygen as the unit. So this was considered relevant due to two reasons. So earlier it was considered like instead of choosing carbon, scientists didn't choose carbon. They choose oxygen. The reason being that it reacted with large number of elements. So most of the elements they reacted with oxygen to form their oxides and compounds. And the atomic mass unit gave masses of the most of the elements as a whole number. So almost all the masses they got their atomic mass as a whole number. So that is why 1/16th of the mass of oxygen was chosen. But later on, it was universally accepted atomic mass unit as carbon 12 isotope was chosen as a standard reference for measuring the atomic masses. So one atomic mass is defined as the here you can see one atomic mass unit. It is defined as mass unit equal to exactly 1/12 the mass of one atom of carbon 12. So this is a relative atomic mass. You see how it is defined? One atomic mass unit is a mass unit equal to exactly 1/12 the mass of one atom of carbon 12 atom. So if you have a carbon 12 atom, you make its 1/12. Okay, so is it Pranav? Pranav? Is your name okay? Is your name Pranav or something else? Pranav, I hope. Okay. So I'll be taking your doubts just before ending the classes. Just remind me for taking your doubts. Okay, the two doubts I'll be taking. Okay. So see, we have one atomic mass. One atomic mass unit is a mass unit equal to exactly 1/12 mass of carbon 12 atom. So whatever be the mass of carbon 12 atom, we make its 1/12, and that 1/12 mass compared with the other masses, it gave a simple whole number that we considered as an atomic mass. Got it? Now, in this way, I will just recall you some of the masses. For example, the atomic mass of hydrogen. If I take the atomic mass of hydrogen, the atomic mass of hydrogen is 1U. The atomic mass of helium is 4U. The atomic mass of sodium is 23. Nitrogen, the atomic mass is 14. For oxygen, the atomic mass is 16. Fluorine, the atomic mass is 19. For chlorine, the atomic mass is 35. So in this way, we obtained the mass of almost all the elements. So for the references, you don't need to remember them all. Most of them, they will be given in the questions. A few of them you may need to remember. For example, carbon has an atomic mass of 12 atomic mass unit. So carbon has 12, nitrogen 14, oxygen 16, fluorine 19, argon 20, potassium, sorry, sodium 23, then magnesium 24. So this atomic mass is a characteristic of every element. Okay. Got this? Everyone understood the atomic mass units? Like here, the atomic mass of different elements is given. For hydrogen, it's 1, carbon 12, nitrogen 14, oxygen 16, sodium 23, magnesium 24, sulfur 32, chlorine 35.5, calcium 40. Okay. Now, we had also discussed how do atoms exist. So some of the atoms, they may exist in their free state, like we can find gold and silver existing in their free state, whereas most of the atoms, they exist in the combined form. So they are not able to exist independently. Most of the atoms, they form molecules and ions. So these molecules or ions aggregate in large numbers to form the matter that we can see. Got it? So atoms generally exist in the form of ions or molecules. For example, hydrogen. In which form do we have hydrogen on Earth? It's a gas. In what form?
They're gaseous form.
No, we have hydrogen on the Earth. We have hydrogen mainly in the form of water, H2O. Okay. So most of the elements, they exist in the form of molecules only. We have carbon present in the form of sugar. We have carbon present in the form of wood. We have nitrogen present in the form of gas, as well as ammonia. We have nitrogen also present as fertilizers. So different atoms, they may exist either independently, or most of them, they do not exist independently. They exist as compounds or molecules. Now let us say, what is a molecule? Okay, just answer this question. Question number 2, why is it not possible to see an atom with naked eyes? Yeah, why is it not possible to see an atom with the naked eye? What is going to do with it?
Sir, because their particle size is very small.
Yeah, atoms are very small to be observed with the naked eye. Okay, so that is why they cannot be seen with the naked eye. Then what is a molecule? It is a general group of two or more atoms that are chemically bonded together. Chemically bonded together means they are tightly held together by attractive forces.
Yes, sir.
So a molecule, it can be defined as the smallest particle of an element or a
That is
compound.
tightly held together, right, sir?
Yeah, it is tightly held together. See what it says. Like I have the smallest element, the smallest particle of an atom or an element of an element or a compound or compound
That is
that,
tightly packed to form an nothing, sir.
yeah, it is tightly held. For example, you have a molecule of hydrogen, that is a hydrogen combines with another hydrogen to form
H2,
H2, a hydrogen molecule. In the same way, we can have an oxygen combining with another oxygen
O2,
to
O2.
form O2 molecule. So hydrogen H2, O2, these are the molecules. This is a molecule of hydrogen.
Sir, we can also define it as two or more atoms combined together, right?
Two or more atoms combined to, then how will you differentiate between a molecule and a compound?
Okay, sir. So two or more atoms that are tightly packed together can be defined as a molecule.
It can be, but then how do you say what is a compound then?
Sir,
What is
it's
the
two
difference
or
between
more
a compound
atoms that are chemically combined in a fixed proportion.
chemically combined in a fixed? Okay, just let's say your doubt will be cleared. Along the class, your doubt will be cleared as we move on.
Yes, sir.
Let's see. Hydrogen is a molecule of hydrogen. So how I say hydrogen is a molecule of hydrogen? See, I have two hydrogen atoms bonded together. So here, let's see, one hydrogen atom, another hydrogen atom bonded together. One hydrogen atom, another hydrogen atom. One hydrogen atom, another hydrogen. One hydrogen atom, another hydrogen. So in this way, how many molecules of hydrogen atom do I have?
Sir, many.
Many. So I can call this is a compound. Okay.
Yes,
This
sir.
is a, here we have different molecules of an element. Okay. These are, I can say, different molecules of hydrogen. This is also H2, this is also H2, this is also H2. So these are all different molecules of an element. Got it? Now see
Got it,
here.
sir.
Okay, now see, we'll see a molecule formed by different types of elements. For example, let's see here. We have the formation of H2O. So H2O, I will show you the formation of H2O. So we have oxygen being represented by others. So here we have one hydrogen bonded with two oxygens. This hydrogen bonded with two oxygens. So this hydrogen also bonded with two oxygens. This hydrogen also bonded with two oxygens. Got it? So the gas here,
Got it, sir.
what we have here, we have this is a molecule of H2O. Okay. This is also a molecule of H2O. This is also a molecule of H2O. Got it? Understood the molecule or not? So here, in this case, in the first case, I have here, this is the smallest particle of element. Got it? It is the smallest particle of an element which you call as hydrogen molecule. And here we have H2O is also a molecule, but H2O is a compound which is formed by the combination of two different elements. Okay. Now out of that compound, there are different molecules. You have different, if you have many molecules together, put together to be called as a compound. Got it? So a compound generally means that there should be a large number of molecules. A large number of molecules combining together to, or being together, a large number of molecules are together forming compounds. Got it?
Yes, sir. So basically, a molecule is the smallest particle of an element or a compound.
Yeah, so a molecule is the smallest particle of an element or a compound. So
Okay,
every
sir.
molecule, every particle of this water, so H2O, it is a molecule.
Yes, sir.
Got it?
Sir, so H2 is the smallest particle of oxygen. Like water is the smallest particle of oxygen, right? In this case.
Yeah, water is, for water, if you have, if you, even if you consider a drop of water, like, so here if I consider just one drop of water, so a drop of water will consist of a number of molecules of water.
Okay, sir.
Okay. So what I say, water is a compound. Okay.
Yes, sir.
Water is a compound which is formed by a number of molecules. Got it?
Yes, sir. Got it.
Yukta? So see, a molecule can be defined as the smallest particle of an element or a compound that is capable of an independent existence and shows all the properties of that substance. Okay. So it will show the properties, all the properties of that substance. Got it? So atoms of same element or of different elements can join together to form molecules. Now, molecule of elements. So we just discussed the molecule of elements like hydrogen, oxygen, nitrogen, carbon, oxygen, all they are the molecules of uh, atoms, and sorry, molecules of elements, and you have molecules of compounds like water, ammonia, carbon dioxide. So is there anyone who remembers the formula of ammonia? Yes. Hussein, I'm listing you some of the compounds. You will try to name them. Just try to name these compounds. Everyone will name. Yukta?
Sir, is it
Yes, sir.
NH3?
Yeah, just name these compounds.
Sir,
So
water.
water,
Water, yes.
Sir, ammonia. Sir, H2O is water and NH3 is ammonia.
Ammonia, very good. Try to
Sir, is
name
that
them.
ammonia chloride?
No, it's not ammonia chloride. It is ammonium chloride.
Ammonium chloride, sorry, sir.
Yukta, everyone try to name all of them. Sampath?
sir,
Sir,
sodium chloride.
sodium chloride.
Sir,
Sodium
salt,
chloride.
common salt.
Yeah, common salt or sodium chloride. H2SO4. Yeah, what is H2SO4?
Sir, H2SO4 is hydrogen sulf. Uh, Sir, it's sulfuric acid, no?
Yeah. So this one is sulfuric acid.
Sir, HCl is hydrogen chloride.
No, HCl is hydrochloric acid.
Yes, sir.
Okay. So this is
Hydrochloric
hydrochloric
acid.
acid. However, it is also called as hydrogen chloride. So
Okay.
hydrogen chloride is also correct.
Sir, is KCl nitrogen
No.
chloride?
Sampath, what is KCl?
Potassium chloride, sorry, sir.
Yeah, it is potassium chloride. CaSO4.
Sir, calcium sulfate.
Yeah, it is calcium sulfate. Calcium sulfate. H2CO3.
Carbonic acid.
Carbonic acid. Okay. So I think you are able to remember most of them. Carbonic acid. Or it is also called as hydrogen carbonate. Carbonic acid is also called hydrogen carbonate. H2O is water, NH3 is ammonia, NH4Cl ammonium chloride, NaCl sodium chloride, H2SO4 is sulfuric acid, HCl is hydrochloric acid, KCl potassium chloride, CaSO4 calcium sulfate, H2CO3 carbonic acid. Got this? So,
Yes, sir.
okay. Now if you find out the ratio of atoms, the ratio by mass and the ratio by mass in all of them will be the same. Always the ratio by mass will remain the same. Then the next is, what is an ion? We also need to understand what is an ion. So what is an ion? A charged atomic species so we can call it an atom or a group of atoms that are charged or that have a charge are called ions. So depending on the amount of charge they have, they are also classified. For example, see, if we take this sodium metal under consideration. So sodium metal Na, this is an atom. This is an atom. And if I write it as Na plus, so Na plus means it is now sodium ion. It is a sodium atom having a positive charge. So sodium atom having a positive charge is called as a sodium
Anion.
ion.
Ion.
Okay, so this is now sodium ion. In the same way, so you need to remember here that sodium atom can have only a positive one charge. Okay, so sodium atom has just a positive one charge or plus one charge.
Sir, plus.
Yeah, sodium atom can have a plus one charge only. So that is why it is called as Na plus, sodium ion. Then we can have potassium. Potassium also have a K plus.
Sir, potassium ion.
Yeah, this is potassium ion. If I just write K, so this represents potassium atom. This is potassium atom. In the same way, there can be negative ions also. So like these are the positive ions.
Sir, I had a doubt in physics. Can I clarify it in the last 5 minutes?
Yeah, in the last 10 minutes, I'll be taking up doubts. There are a number of doubts, so I'll be taking the last 10 minutes.
Yes, sir.
So there can be negative ions also. Like if I write O2, so this is oxygen atom.
Oxygen atom.
Sorry, oxygen molecule. O2 is oxygen molecule.
Molecule.
If
Sir,
I write,
H2 is also oxygen molecule, right?
yeah, O
No,
means
hydrogen
oxygen.
molecule. Hydrogen molecule. Sorry,
Yeah,
sir.
O is oxygen atom. And if I write O negative 2,
Sir, is
so
it
this,
oxygen ion?
so oxygen ion is called as oxide ion.
Oxide ion.
A hydrogen having a charge H, just like H, it is hydrogen atom. Okay, this is hydrogen atom. If you have H plus, so
Sir, hydrogen ion.
yeah, so this is hydrogen ion. And what will be H minus?
Sir, hydrogen
Hmm?
ion.
Which ion?
Sir, hydrate. No,
We call it as hydride ion.
hydride ion.
So this is chlorine atom.
Sir, it's chlorine atom. Cl plus will be Cl2 will be chlorine ion.
Cl2 will be chlorine molecule.
Molecule.
Pranav, Yukta, Harshit, you are not responding. Harshit,
Yes, sir.
you are not responding. Hmm?
Okay, sir.
So this class is just not for one person. The more you will get benefit, the more you are active. Okay, you will get benefited more. So either you keep your camera on or be active. I'm not going to look at your cameras every time. Okay? You can Uh, I have already told you that you are free to eat something, drink something, but just be there in the classes. The camera should be on just to see that you are there in the class. Okay, see. Then this Cl,
Sir, it's chlorine atom.
Harshit,
Cl2, okay, sir.
Harshit,
Yes, sir.
what is Cl minus?
So chlorine atom.
It's not chlorine
Sir,
ion,
it's
it's
chloride
chloride ion.
ion.
We call it as
Chloride ion.
chloride ion.
Chloride ion.
Okay. Like if I ask you the difference between N, N2 and N minus 3. So what is the difference?
Sir, N is an atom, N2 is an molecule, N minus 3 is an ion.
Okay. So Harshit, what will be the name of N minus 3?
So nitrate.
Sir, nitrite ion, no?
Yeah, Harshit, what will it be?
So nitrate ion.
Nitride ion. So N minus 3 will be nitride ion. N will be nitrogen atom and N2 is nitrogen molecule.
So what does it do? Is it the molecule or
Which one?
it?
Sir,
Which
N2
one?
is a molecule.
N2
So it
is
is
a
N2 and
molecule.
molecule. Okay, sir.
So N2 is a molecule. Got it? So up to now we have seen ions which can be either positive or negative, but they are made up of single types of atoms. We can also see ions which are made up of more than two types of atoms. For example, we have a ion which is hydroxide ion, OH with a charge of -1. So this ion is called as hydroxide ion. This is hydroxide ion. We can have an ion is also write CO3 with the charge of -2. So this
Sir,
ion is called carbonate ion.
carbonate ion.
Yukta, what will be the name of this? S-2.
Sir, sulfur ion.
Sulfur, not sulfur ion, it will be sulfide ion.
Sorry, sir. Sulfide ion.
This is sulfide. S is sulfur. When I write S, it is sulfur. If I write S-2, so this is sulfide ion.
Sulfide ion.
Sir, what will be with S-1?
Which one?
Sir, S-1.
No, see, every ion has a certain specific amount of charge, which depends on the electronic arrangement of that atom, how the electrons are arranged. So depending on that, the ions have a fixed charge. Okay, and some ions, they do have some variable charges, but still they cannot have anything. Like you cannot write S-10. If you write S-10, so this is not possible. Okay, so that is why you may need to remember them, that what is the valency or what is the charge of each one. Okay. So now I'll be taking your doubts. We have last 20 minutes, so I can take up the doubts one by one. So starting, we have a doubt from Pranav regarding eukaryotic and prokaryotic cells. So for today's doubts, we have eukaryotic and prokaryotic. So see how we identify U and pro. The word EU, it means true.
True.
Okay. Karyo means nucleus. So those cells which have a true nucleus. Okay. So cells with true nucleus. So when I say true nucleus, it means the nucleus is bounded. We have a bounded nucleus. The nucleus has a boundary. It is covered with a nuclear membrane. Okay. Bounded nucleus. So there is a nuclear membrane around the nucleus. So such a cell will be called as an eukaryotic cell. So apart from having a bonded nucleus, there are certain other features which are available in the eukaryotic cells. Okay. Like the eukaryotic cells, they have a eukaryotic cell, it has presence of an eukaryotic cell, it can have presence of membrane bound organelles. It has the presence of membrane bound organelles like ER, that is endoplasmic reticulum, mitochondria, ER or mitochondria, they are present over there. Lysosomes, all of them, they are found in these. Whereas also the DNA, they have DNA as the genetic material. Whereas for prokaryotic cells, so pro means it's not well developed. It is at the stage of development. So not well developed. It is at the stage of development. Karyo means nucleus again. So when the nucleus is not well developed, that means the nucleus does not have a nuclear boundary or nuclear membrane around it. So we call such a cell to be a prokaryotic cell. So here we can write nucleus is not well developed. You can see nucleus is not well developed in a prokaryotic cell. So apart from nucleus not being well developed, these cells are actually not well developed. So they also lack membrane bound cell organelles. Membrane bound cell organelles like ER, that is endoplasmic reticulum, and other things, they are not present over there. Endoplasmic reticulum, mitochondria, DNA, they are absent. No mitochondria which is found in prokaryotic cells. There will not be any endoplasmic reticulum. There will not be DNA. So the genetic material is present here in the form of RNA. So they have genetic material in the form of RNA. In the form of RNA. Got it? Understood, everyone?
Yes, sir.
So this was the difference between a eukaryotic cell and a prokaryotic cell. You can give them examples of prokaryotic cells like uh, Archaebacteria, eubacteria. They are the examples of prokaryotic cells. All the bacteria, they are the examples of prokaryotic cells. Okay. Then you had some other doubt also. So what was the other doubt, Pranav? Okay, there is someone, I think this is the doubt Rohit is having. Yeah, Rohit is having a doubt in physics. Let's clarify it, then I will
The
see.
second chapter.
Second doubt. Yeah, you have
Second
to see also
chapter
the
in
difference between
physics. Sir,
osmosis
it's
and.
from the exercise.
Yeah, this question is from exercise.
Yes, sir. Question 17 in the NCRT textbook.
Okay, just 1 minute. Let me copy it. I will have here the question. Okay, so Akhtar and Rahul were riding in a motor car that was moving with a high velocity on an expressway when an insect hit the windshield and got stuck on the windscreen. Akhtar and Kiran started pondering over the situation. So Kiran suggested that the insect has suffered a greater change in momentum as compared to the change in momentum of the motor car, because the change in velocity of the insect was much more than that of the motor car. Akhtar said that since the motor car was moving with a larger velocity, it exerted a larger force on the insect, and as a result, the insect died. Rahul, while putting an entirely new explanation, said that both the motor car and the insect experienced the same force and a change in their momentum. Comment on these situations. Okay. So, is there anyone who would like to put any comment over here about this answer?
Sir, how do I answer this question? I didn't understand.
So, you have to explain, you have to explain about Akhtar, you have to
Sir,
explain about Kiran, you have to explain
Yes,
about
sir.
the Rahul's statement.
sir,
Yes.
sir, here Rahul is correct, sir, because of law of motion.
Yeah, because of the third law of motion, every action has equal and opposite reaction.
Reaction.
Okay, so since every action has equal and opposite reaction, therefore, the force experienced by the car or by the windshield as well as by the insect is the same. But since the insect had a smaller mass, so it suffered a greater change in velocity, whereas the car had a higher mass, so it suffered a smaller change in velocity. So change of momentum on both of them is the same, as momentum combines both mass and velocity.
Yes, sir.
Okay. So here Rahul's statement is correct.
Sir, because it's related to the third law of motion, right?
Yeah, it was related to the third law of motion.
Okay, sir, I got it.
Then
Thank you,
next
sir.
doubt is from osmosis and diffusion. So understood the answer here? The answer is Rahul's explanation is correct. As it is in accordance with Newton's third law of motion. With Newton's अब तुम अपना क्लास क्यों नहीं अटेंड करते हो क्लास क्यों नहीं अटेंड करते हो पढ़ना नहीं है हाँ? लर्नर से पढ़ता हूँ नहीं तो तुम क्यों नहीं कर रहे So here Rahul's explanation is correct as it is in accordance with the Newton's third law of motion. Got it? Now we have to say the differences between osmosis and diffusion. Okay, so what is osmosis? What is osmosis? See, osmosis, it is the movement of water molecules or solvent particles. So generally the solvent is water, so that is why I can write it as it is the movement of water molecules of water from region of from region of low concentration to high concentration. And also for osmosis to occur, there it is a necessary condition that there should be a semi-permeable membrane between the two solutions. Two solutions must be separated by a semi-permeable membrane. Okay, anyone else having any doubt? So in case of osmosis, it is the movement of water molecules from a region of low concentration to a region of high concentration. Like you can observe the swelling of resins. Swelling of resins soaked in water. So this is an example of osmosis. Here we find the movement of water molecules from water in a container to the resins. Now diffusion. Diffusion is the movement of solute particles. It is the movement of solute particles. Also see here, there is no necessity of semi-permeable membrane. No membrane is required over here. Diffusion can occur without any membrane. And also it is the movement of solute particles from high concentration to low concentration. So from region of high concentration to low concentration. Like you have the smell of an agarbatti in your room. That is an example of diffusion. Okay, the smell of perfume in your room. It is also an example of diffusion. Got it? Any other doubts? Yes, any other doubts?
No, sir. Sir, I had one more doubt regarding the same question.
Yeah, what is the question?
Sir, do I also have to explain why Kiran and Akhtar's explanations are not right?
Repeat again.
Sir, I'd asked you that question, right? Sir, after we say that Rahul's explanation is right, Do we
Mhm.
also explain why the other two's explanation is not right?
Yes.
Okay, sir.
Okay. Okay. Bye, all of you. See you again in